Alright, in this video I will show you how to graph exponential functions, and in the end don't forget that we're being asked to find the domain, the range, the x-intercept, the y-intercept, and the asymptotes. So as we've done with all of our functions, the key is to make a table of values. So please understand that the table of values begins with the parent function, which is simply 2 to the x power. So to graph this problem, this is what I would do first. I would make a little table like this. Now some of my students get confused because late in the game we started graphing logarithms, and they got logarithms stuck in their brains. This is an exponential function. Am I going to start with the x's or am I going to start with the y's? See, I just heard both answers, okay? Most recently we've been doing the y's, but that's because most recently we were graphing logarithms. It's logarithms that start with the y's. For exponential functions such as this, we're going to start with the x values like you've done all your lives, okay? So that's why I'm going to start with the x values of -2, -1, 0, 1, and 2. Start with the x values. And again, I'm just doing the parent function right now. So I'm just doing 2 to the x power. So that means I'm doing 2 to the -2 power, and 2 to the -1 power, and 2 to the 0 power, and 2 to the 1 power, and 2 to the 2 power. I recommend working from the bottom up. So 2 squared, of course, is 4. 2 to the 1 power is 2. Anything to the 0 power is 1. The top 2 numbers will be the reciprocals of the bottom 2. So this is going to be 1/2. And I hope you don't mind if I just go ahead and put 0.5, because that's going to be more useful to me later. And the top one would be 1/4, but I'm going to go ahead and put 0.25. So this is the parent function. Have I lost anybody so far? Okay. So just like we did in the last unit with all kinds of random functions, we will now consider any transformations, and we will use those transformations to make a new y column or a new x column. Okay, so this particular problem is only going to have a new y column. All right, anything outside the function is going to produce a new y column. All right, there's nothing happening inside the exponent, so only the y's. So this is going to be true. So I have 5 and I have this 2. So my new y column is going to be 5y plus 2. All right, so look, you can use your 4-function calculator to help you with this. You're only going to have a 4-function calculator, so be warned about that. Quit. All right, so pretend I had a 4-function calculator. I could still do 5 times 0.25, and then I could do plus 2. Okay, so that's 3.25. Okay. 5 times 0.5, and then I could do plus 2. All right, that's 4.5. Okay, 5 times 1 plus 2, of course, is 7. 5 times 2 is going to be 12. And 5 times 4 plus 2 is going to be 22. Okay, so I have a new y column, so I'm going to disregard the old y column, and I'll plot these points. Don't forget that the original asymptote, exponential functions, do they have vertical asymptotes or do they have horizontal asymptotes? Horizontal. Okay, these are only logarithms have the vertical asymptotes, so these are going to be horizontal. It normally would be the x-axis, but in this case, what is it going to be? It's going to be up at 2 because of this vertical shift. of plus 2. So please understand, I will have a horizontal asymptote at 2, and you should show that asymptote as a dotted line like I'm doing right now. All right, after that, you can just plot the points. So negative 2, comma 3.25 would be about here. Negative 1, comma 4.5 would be about here. 0, comma 7 would be about here. 1, comma 12 is going to be here. And then 2, comma 22. All right, okay, that's a little bit off the grid, but you get the idea. Okay, and then you just want to sketch that curve as best you can. So it's going to look something like this. Okay, but don't forget, that's not enough. We've only done 2/3 of the problem. In addition to sketching the graph, which is now complete, we need to go back and say the domain, the range, the x and y intercept, and the asymptote. So let's do that real quick right now. Let's see, the domain. Okay, the domain is negative infinity to positive infinity. The range. The range is going to be from 2 to infinity. Parentheses, not bracket. Okay, the x-intercept, oh God, there is no x-intercept on this particular problem. All right, x-intercept, I'm just going to put none. It doesn't touch the x-axis. For the y-intercept, well, I can see it right here. It's 0, comma 7. All right, so that's it for problem number 23. All right, let's go ahead and do problem number 24 the same exact way. So I'm going to make my little table of values, starting with the parent function. For exponential functions, we start with the x values, negative 2, negative 1, 0, 1, and 2. Okay, remember, I'm only doing the parent function right now, 2 to the x power. So I'm just doing 2 to all of these powers. So I'm doing 2 to the negative 2 power, 2 to the negative 1 power, 2 to the 0 power, 2 to the 1 power, 2 squared. So this would be 4, 2, anything to the 0 power is 1. These two will be reciprocals of the bottom two. So the next would be 1/2, but I'm going to put 0.5. And the next would be 1/4, which would be 0.25. And if you watch the video for the previous problem, they're the same values. Okay, so I'm going to need a new y column because both of these transformations are going to affect the y values. All right, to form the new y column, I'm going to do 2y minus 2. And that's coming straight from these transformations. All right, the 2y minus 2. Okay, so use your 4-function calculator if you want to. So it's going to be 2 times 0.25 and then minus 2. So that's negative 1.5. Oh, wrong thing. Okay. So of course, if I do 2 times 0.5, that's going to be 1. Then minus 2 is going to be negative 1. Okay, so this is just going to be 2 minus 2, so that's going to be 0. And this is going to be 4 minus 2, so that'll be 2. And then 2 times 4 is 8 minus 2 will be 6. So I have a new y column, so I'm going to ignore this and plot these. Please remember that the exponential functions have horizontal asymptotes. Normally would be the x-axis, but because of the vertical shift down 2, which you can see right here, the asymptote is going to be way down here at -2. Oh, I just realized on the previous problem we were supposed to mention the asymptote on that as well. So this asymptote is y equals 2. Okay, I forgot to mention that. Anyway, so now I can just plot these points. So -2 comma -1.5 would be right here. -1 comma -1, 0 comma 0, 1 comma 2, and 2 comma 6. All right, so this function is going to look something like this. All right, the domain is -infinity to +infinity. The range is going to be from -2 to infinity. The x-intercept is 0 comma 0. And it turned out to be relatively easy, so you can just see it right there. And that's also the y-intercept is also 0 comma 0. And then the asymptote is y equals -2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.